Okay, this is Mr. Weideman, and this is the 6th video for our Lafayette High School Functions in Trig Chapter 5 practice test. This one here is by far the most challenging problem that we have. It's tedious and the math is icky. The process is not different. The process, got to know that t-table, got to be able to recognize the translations and apply them correctly. All right, for our tangent and cotangent and our inverse functions, we really don't define them as having an amplitude, so that coefficient of a equal 1/2, that is just going to be merely a vertical shrink. We do have a change in period here. The period for tangent and cotangent is not 2 pi, it's pi. I'm still going to divide that by b. Remember, this is a translation applied to the x value, so it's opposite of what you think. So instead of multiplying by 3/4, my translation is divide by 3/4. Same thing as multiplying by 4/3. Phase shift, all right, my horizontal shift, I have a B and a C. This is a special case, so I always have to take my horizontal shift and divide it by the coefficient in front of the x. And when we do that here, that's really nasty. Okay, 4 pi over 9 is nasty. So when we have to, in this case, what do we have to do? It's to the left. So we have to subtract that 4 pi over 9. And admittedly, not much fun. All right, so let's get to it. Start off with our t-table. Got to have this committed to memory. No ifs, ands, or buts. All right, because we always do our translations from a t-table. There's other ways to do it, but that's the way that we've learned it how to do in this course. All right, so order of operations is important. So the two things that I can do first are I can divide my x values by 3/4, and I can multiply my y values by 1/2. So we can do that, and I know what to do. Okay, the math isn't a whole lot of fun. Having a piece of scratch paper here is nice. I know that dividing is the same thing as multiplying by the reciprocal. I reduced my fractions here, because when I did reduce my fractions, everything has a denominator of 3. So that's going to be easy to plot. There's some other example problems here where I did not reduce it because I wanted them all to have the same denominator for plotting. And we'll see that in some of the next examples. Okay, I can multiply by 1/2. Okay, this is important. Now that phase shift is the last thing I do. Look at your foldable, and it tells you the order in which you do these. If you do not do them in correct order, you'll get them wrong. 4/9, okay, yeah, that stinks. All right, so I got to get a common denominator of 9, and just, it's kind of icky. It's a little bit tedious. There is a way to make it a little bit easier. Negative 10 pi over 9, negative 7 pi over 9. We know that these are periodic functions, meaning there's a pattern. What's happening to my x value? It's decreasing by 3 pi over 9. Negative 10, negative 7, negative 4, negative 1, positive 2. So you can really reduce a lot of your math by understanding, picking up on the pattern. Do the math once and then pick up on the pattern. can save you some time. Okay, so that is going to be my t-table. All right, now on the actual test, I'm probably not going to give you something quite this icky, and plotting this is going to be kind of a pain in the, because our graph is designed for multiples of pi over 6 and pi over 4 and not pi over 9. So yeah, this part really stinks. So what I do, I kind of modified here. We do have our graph set up in pi over 3s, which is a multiple of pi over 6. And what I did is I took these guys, okay, I took those tick marks, and I just gave them a common denominator of 9. I just multiplied the top and bottom of each fraction by 9. So I would get kind of a idea on my graph here where things with a denominator of 9 went. Okay, so then from there, then it's just kind of like, okay, well, close enough sort of thing. Where is negative 10 pi over 9? Well, it's somewhere between 9 and 12. It's actually 1/3 of the way across, right? So that's how I figured that out. Approximate is fine. Same place. Okay, where is negative 7? Well, somewhere between the 6 and the 9, so on and so forth. And a little tedious getting that thing in there. We know what a tangent function is supposed to look like. And once you get those asymptotes set in and whatnot. All right, again, probably on the test, we're not going to have something that's scaled quite this icky. All right, if you can do this problem, you can do anything. All right, more importantly, understand how to do it. Understand the math. Okay, it's working with fractions. Okay, so be very proficient at that. All right, let's look at this one. This one is dirt simple, although you will get it wrong unless you know your t-table. Okay, if you have your t-table memorized, then this problem is just a total give me. I've just got one translation. It's a vertical shrink. I multiply all my y values by 4/5, and bam, you're done. And now we're ready to plot this thing. Okay, backwards S curve, done. Okay, back to being tedious again. What do I have? I have a vertical stretch. I've got a upward shift of 0.3, and I have a horizontal shift. Okay, remember that 3? It's not in the parentheses, so I apply it to the y. My phase shift, -3 divided by b, in which this case is just 1. It's a rightward shift. So I add, which is a little bit easier than subtracting. Right? Again, I have to know my t-table. Okay, order of operations. Make sure that you apply these correctly and in the right order. I have to multiply the y by 3 first, and then add the vertical shift. If I don't do it in order, I will get it wrong. This time here, I left things in my mathematics, pi over 3. I just left things as a denominator of 6 because I know my graph increments are pi over 6. So when I go to graphing this thing, it was easier just to leave it in pi over 6. So that way I can just count tick marks and be done with it. And then last but not least, I apply that vertical shift up. I scale this graph so it looks nice and plot my stuff in there. And this is where it was nice to leave all of my x values as unreduced fractions. Max becomes mins, mins become max, and this video is getting really long, so we're going to go through the last problem pretty darn quick, and that's okay because it's easy. It's just got one shift to the right. Yep, so that means I add, and that is the only thing I have to do to add pi over 3 in my t-table, which means I need a common denominator of 6, and that's the only translation. Little tedious to plot, but not that bad. Remember, these little increments on the bottom are in pi over 6s, so I can just count. I did a little bit more counting over here just to put in another asymptote just to make my graph a little bit prettier. And there is my graph, and we're done. Super important on this test, a lot of graphing trig functions. If you're not proficient in this, there's just no way you're going to do well on this test. If you are proficient with this, you're going to do well.